To illustrate the algebraic approach to finding the instantaneous rate of change, or the derivative at a point, let's look at our fourth problem in the web work. So here we're asked, compute the derivative of y with respect to x at 3. So we're finding the instantaneous rate of change at the point 3. And our function f of x, or y, is equal to x squared plus 2x. And so the steps that we outlined on the slide that you should have read are summarized here. First, we're going to calculate y of 3, and then we're going to calculate y of 3 plus h. So I have a little scratch pad here that I'm going to open up. So our function our function f of x is x squared plus 2x. And we start by saying, what is f of 3? So using substitution is 3 squared plus 2 times 3. Don't like the format there. Plus 2 times 3, which is 9 plus 6 is equal to 15. Alright, so that's our first step. We've found the point. And so this is the y value of the point where we're calculating the slope. The next step is to calculate the value at 3 plus h. So f at 3 plus h. So this time our input is 3 plus h. So we'll substitute 3 plus h, and I lost my thing again. So it's 3 plus h squared. So we're substituting everywhere we see x in the original formula, 3 plus h, plus 2, and again 3 plus h substituted for x. So this is the value, but what we'd like to do is we'd like to expand that. So when I expand 3 plus h squared, I'm going to have to FOIL that out, plus the second term we can distribute right now. 2 times 3 is 6, and 2 times h is 2h. So let's expand now. 3 times 3 is 9. Outside is 3h. Inside is another 3h. h squared, 6, and 2h. And now we can collect all those terms. So what do we have? We have a 9 plus a 6 is 15. We have 3h, 3h, and 2h, so that's 8h. And we have h squared. Alright, so this value, the 15 plus 8h plus h squared, that's our expression for f of 3 plus h. So 15 plus 8h plus h squared. Double check that we got that right. Alright. So the next step is to calculate the difference. So this is calculating the rise of my function between those 2 points. So f of 3 plus h minus f of 3 is going to be the expression 15 plus 8h plus h squared. And we're going to subtract the value f of 3, which is 15. And so we can see that the 15's cancel. We're left with 8h plus h squared. So that's the value of the rise, the delta f. So we have 8h plus h squared as the rise. And our next step is to calculate the difference quotient. So it's the rise over the run, and the run is always h. So we can't divide by 0, but notice that when I take 8h plus h squared divided by h, I can actually cancel one of the h's. So when I calculate, let's see if this works, the fraction of 8h plus h squared over h, oh, didn't like that. So I'll just write it out as a regular fraction. 8h plus h squared all over h. So I want to be careful, I should put that in parentheses. I can do that if I factor out the h in the numerator. So that's h times 8 plus h over h. Now that I have common factors, the h over h cancels, and I'm left with 8 plus h. So in our exploration of the dynamic activity, remember there was this hole on the right pane that represented the slope. And by canceling the h, we're finding out what that value is going to be for all values including h equals 0. So the difference quotient simplified to just 8 plus h. So let's just remind the space up above, this is the change in the height, and when I divide by h, this is now the rate of change. This is the average rate of change as a function of h. And the derivative, or the slope of the tangent line, is what that the slope of the chord is as h goes to 0. So we get h turning to 0, we get a value of 8. All right, so this is our value. And we got, what did I do wrong? I think I must have an error checker wrong. I'll fix that, but this is the right formula. And by the time you're able to do the problem, that'll be correct. All right, so that's how we calculate the derivative at a point. And so you can go ahead and try answering the same answers for your problem 4, and then go on and try problem 5. It's essentially the same problem with a slightly different function. All right, I'll see you Monday.